Hello everyone. Our B project topic is design and implementation of single channel analyzer in nuclear applications. Our guide is Mrs. Kanchan Savan ma'am, and I am Sanya Mahajani, and my team members are Shushti Gharat, Rahul Maurya and Ritiksha Matre. So this is the block diagram of our project. First, there is a window comparator which consists of two Schmidt triggers with threshold voltage 3 volt and 5 volt, for which we have used IC LF356. Then a monostable multivibrator using IC SN74123 provides delay and holds the output so that the counter can count. The AND gate gives logic high and low for the valid pulse. As you can see from the diagram, the second pulse is the valid pulse, which is above LLR and below ULR, for which the AND output is 1. The counter counts the valid pulses and a handheld device displays the count of the pulses.
So from the first review, there are total main 3 suggestions given by the reviewer. One is to add the new feature. So we started by changing the Schmidt trigger IC, that is 741, which is commonly used. This time we are using LF356, which has more benefits over 741, like more slew rate, high input impedance, and overall great performance. Second one is we are using LF356, and here we have set the threshold value for the upper and lower Schmidt trigger and also calculate the values of the potentiometer, which is shown in the slide. We are using a counter, which is a, which is the add-on for our circuit. We will be using the 80 tiny board, which operates between the 2.7 and 5.5 volt, and it measures the time interval between two consecutive logic level transitions. For the hardware implementation, we implemented the window comparator of a threshold 3 to 5 volt using LF356. The output of that circuit is given to the monostable multivibrator, which is operated on 5 volt. Here, we are also using a NOT gate, which is used to invert the output of a ULD, which will be given as a one of the input of a monostable multivibrator.
As was suggestion given by our mentor, we have read the latest research paper. In that, the circuit diagram and the logic was very similar as compared to our applications. In the research paper, they have used the microcontroller, and in our application, we have used the monostable multivibrator. The rest are very similar.
Okay, so now we would be looking at a hardware implementation. Here is the short video of what we have worked on. So, S. Here is the circuit that we have implemented. SCA produces a logic output pulse if input pulse amplitude lies between two preset levels, that is between ULD and LLD. So to obtain this logic pulse, we have implemented Schmidt trigger using LF356IC between preset threshold, that is 3 volt to 5 volt. The action of this unit is to select a window in which input amplitude must fall between set threshold in order to obtain the logic output pulse. Next, the pulse from ULD is given to NOT gate, which inverts the pulse. Further, the output of NOR gate is given to 74123 IC, which operates as a monostable multivibrator. The monostable multivibrator provides a time delay and holds the logic output pulse so that counter can count it. The trigger input given will be of very short duration just to initiate the action. Now we would be looking at the output. The first picture illustrates the output of this Schmidt trigger using LF356IC. In the second picture illustrates the inverted pulse arising from the NOT gate. Then we have preset the threshold in the picture. In the picture shown, we have preset the threshold as 5.7 and the monostable is triggered.
Project timelines. We have divided the project timelines into two milestones. First milestone is a limitation of OPAM of 741 and the studying of AD8561 and LF356 IC. Second milestone is implementation of SCA, which consists of ULD, LLD, and monostable on hardware. First milestone is divided in 4 tasks. Second milestone is divided in 2 tasks. In the task 1, we have revised the concept of differential discriminator in detail. In the task 2, we have calculated the pulse width of monostable that we have got from the formula as well as from the observation. In the task 3, we came across the limitation of OPAM 741 IC and also the heating of monostable, and to overcome this limitation, we have replaced the 741 IC with LF356. In the task 4, we have studied the key difference between LF356 and AD8561, and we have opted to go for the LF356 due to the favorable characteristics and suitable for our application. In the task 5, we did the hardware implementation of LF356, that is acting as the window comparator, and also studied research paper, and we have gotten the desired output. In the task 6, we have implemented the ULD and LLD between the two threshold values and also implemented the mono by connecting through NOT gate, and the mono output was obtained. Reference. Here are some of the references that we have referred during our project journey. So that's all. Thank you.